All right, now we know how to set up one set of parameters within OpenAI Lab. What if we want to run a much bigger experiment with lots of different parameters that we want to test over? So lots of different, for example, neural network architectures that we want to experiment over. Well, it's pretty easy. So all we need to do is we are currently in our OpenAI Lab directory. We can change directories into our reinforcement learning specs directory. Let's have a look at everything that's in there. Now, when we go into the classic experiment specs, we can see a number of different experiments. One of these that I'd like to return to now is this DQN experiment, all lowercase. So what I didn't point out when we looked at this quickly earlier is that we now have this parameter range setting. So within this parameter range setting, we try out a number of different things. So we try having a number of different learning rates for our atom optimizer. So we start our atom off with various learning rates, and we can grid search over these 4 levels. So our gamma, we're going to vary this as well. So we're going to start with 95%, 97, 99, 99.9%. And then the part that I think is most fascinating is playing around with the number of hidden layers in our dense network. So this is the dense network that these theta parameters that are approximating our optimal Q here. So there are 5 currently in this file. So one of them has a single hidden layer with 16 neurons. Another one of them has a single hidden layer with 32 neurons. Another has a single hidden layer with 64 neurons. Then we have this 4th one with 2 layers. The first layer has 16 neurons. The second hidden layer has 8. And then finally we try a 2 hidden layer model with 32 neurons in the first layer, 16 neurons in the second layer. So we can try out those various parameters. Now to run this DQN experiment, we can head back to our config file. And we can have a look in there. We can set our default .json to, we can change the experiment name to DQN. And now, instead of running grunt with the best flag, we are going to remove the best flag that we've been using previously. And now this will not produce graphic output for us as it runs, but it's going to run over a grid search over all of these possible parameter range permutations. So it's going to try out this learning rate with all of the various gamma parameters and all of the various hidden layer configurations that we specified. And so that's just going to run on your machine. It's going to go on for quite some time. And we're actually not going to sit here for however long this takes. It might take hours. So we're going to cancel that. We're going to go have a look in the data directory, see what's in there. And so we can see that running that experiment caused this log to come up. So we can see, so this is the same thing that was just showing up in my terminal a moment ago. So you can examine the log in detail if you want to. And then in addition to that, this will fill up with summary files for each of the experiments that you specified for your grid search. When the experiment ends, you will end up with a plot output comparing the various hyperparameters that you set up against each other in a really convenient graphical display. So to have a look at an example of one of those, I want to draw your attention to this part of the OpenAI Lab documentation called the fitness matrix. So we're going to talk about fitness scores in a moment. They are a contrived metric that we make up as the user to have an overall assessment of the quality of our reinforcement learning agent. So we'll talk about how to define that momentarily. But before then, suffice to say, higher scores on the same task represent a more fit model. So we've been playing around with the DeepQ learning network, playing the Cartpole version 0 game. So if we click through this link, we can see the files that Kang set up for this experiment. And these are very similar, if not identical, to the JSON file parameters that we were just looking at. And then we can scroll down to these charts comparing the performance of the various hyperparameters that we had. So recall that we had 4 different levels of gamma. We had various configurations of hidden layers and various learning rates that we compared our results over. So now we can see, for example, that the fitness score for the networks that had 2 layers, so this 16 and 8 or this 32 and 16, so either of the 2 hidden layer neural networks that we put into this deep reinforcement learning algorithm, they ended up having by far the worst fitness. So you can see that the fitness scores were much higher for these single hidden layer networks. There's other stats here like the mean number of rewards or the maximum total rewards, and we can similarly see that those 2-layered neural networks underperformed the other configurations. So this kind of chart enables you to run your own experiments, come up with various configurations, particularly of the deep learning neural networks within these deep reinforcement learning models, and you can compare performance and come up with really great high-performing agents. The last thing that I want to talk about with respect to OpenAI Lab is delving deeper into this fitness score, so we're going to do that next.